Hello students, next topic is mean and variance of binomial distribution. Mean has formula NP and variance is equals to NPQ. Now we will start the questions. First is prove that mean of binomial distribution is always greater than variance. Is always greater than variance. Now we know mean has formula NP and variance is NPQ. So mean minus variance, NP minus NPQ, take NP common, 1 minus Q, 1 minus Q, we know P plus Q is equals to 1, total probability is always 1. So 1 minus Q is equals to P, and P square, that is greater than 0 because N belongs to natural number greater than 0 and P probability is always greater than 0. So NP square is greater than 0. It means mean minus variance is greater than 0. That is mean is greater than variance. So mean is greater than variance. Now the second one. Question number 2. A die is thrown 20 times. A die is thrown 20 times. Getting a number greater than 4. Getting a number greater than 4 is success. 3. The mean and variance of binomial distribution. The mean and variance of binomial distribution is 4 and 4/3 respectively. The mean and variance of probability distribution is 4 and 4/3 respectively. Find probability x greater than equals to 1. Now mean is 4, variance is 4/3. If we divide this equation, NPQ upon NP, 4/3 upon 4, so we get the value of Q here. Q is 1/3, P is 1 minus Q, 3 minus 1, 2/3. Now probability x greater than equals to 1. Now first we have to find the value of n. NP is 4, P is 2/3, so n is 6. Probability x is greater than or equal to 1. We can write it as 1 minus probability x is less than 1, that is 1 minus probability x is equals to 0. N is 6, so 6 is 0, P 0, Q 6. 6 is 0 has value 1, Q is 1/3, so 1/3 power 6. So 1 minus 1 upon 81 into 9, 729. 1 minus 1 upon 729, so 728 upon 729. So what we have done here, we have the value of mean and variance. From here we have found the value of P and Q. After knowing the value of P and Q, find the value of n and put this value of n, P and Q in this formula and get the result. Now next one is question number 4. A die is tossed thrice. A die is tossed thrice. Getting an even number. Getting an even number is considered as success. Getting an even number is considered as success. What is the variance of binomial distribution? What is the variance of binomial distribution? A die is tossed thrice, so n is 3. Getting an even number is success. Probability of getting an even number is dice 2, 4, 6. 3/6, that is 1/2. Q is 1 minus 1/2. Now we know the formula for the variance is NPQ. N is 3, P and Q. 1/2 into 1/2, so 3/4. Variance is 3/4. Next question is find the binomial distribution. Find the binomial distribution for which mean is 4 and variance is 3. Mean is 4 and P is 1 by 4. So N is 4 into 4, that is 16. So N 16, P 1 by 4, Q is 3 by 4. What is the binomial distribution? NCR, PR, Q, N minus R. R takes value from 0 to N. So probability X is equals to R is equals to 16 CR N is 16, P is 1 by 4 power R, Q power 16 minus R. R has value 0 to N. N is 16 here, so we can write the value here 16. Now the next one is question number 6. If the sum of mean and variance of binomial distribution, if the sum of mean and variance of binomial distribution for sum of mean and binomial distribution, mean and variance of binomial distribution for 5 trials is 1.8, find distribution. Sum of mean and variance is given for the 5 trials. So N is 5. Mean plus variance has value 1.8. Formula for mean and variance. NP is common. 1 plus Q is 1.8. N has value 5. So 5P, or we can write it as 5P. We can write value of Q as 1 minus P. So 5P plus 5P minus 5P square is 1 by 8. So 5P square minus 10P plus 1.8 is equals to 0. Take 5 common, P square minus 2P. We can write it as 18 by 10 by taking 5 common. So this becomes 18 by 50, that is 0.36. P square minus 2P plus 0.36. So factors are P minus 0.2 and P minus 1.8 is equals to 0. So P has value 0.2 and 1.8. Because P is not greater than or equal to 1, so this value will be rejected. So P has value 0.2. So Q is 1 minus P, 0.8, and we have 5. So the distribution is NCR, PR, Q, N minus R. R takes value 0 to 5. So this is the required binomial distribution. Next is question number 7. distribution are 24 and 128 respectively. 24 and 128, find our distribution. Now mean and variance has sum 24. NP plus NPQ is 24. Take NP common, 1 plus Q is 24. So value of NP is 24 upon 1 plus Q. Now product is given, mean into variance has value 128. NP into NPQ is 128. So N square P square into Q is 128. Value of, we had no, now we know the value of NP and N square P square, 128 upon Q. N square P square is equals to NP square. So 128 upon Q, 24 upon 1 plus Q whole square. So 128 upon Q, A plus B whole square, A square plus B square plus 2AB, 4 into 6. Q is equals to 9 upon Q square plus 2Q plus 1. Here we have quadratic now. So 2Q square, 2 into 2, 4Q plus 2 is 9Q. 2Q square minus 5Q plus 2 is equals to 0. Now factorize the quadratic. By multiplying we want 4 and by adding and subtracting we want 5. So 2Q, Q minus 2. So Q minus 2, 2Q minus 1 equals to 0. So Q has value 2 and 1 by 2. But Q should not be greater than 1. So this is not the value, value will be rejected. So we have the value of Q as 1 by 2. Now P is 1 minus Q, 1 minus half, 1 by 2, 1 by 2. Now NP plus NPQ has value 24. P is 1 by 2, Q is also 1 by 2. From here we can find the value of N. N into 1 by 2, 2 plus 1, 3 by 2 is 24. So N is 4 into 8, 32. So the binomial distribution is NCR, PR, Q, N minus R. R is 0, 1, 2 up to 32. So this is the required binomial distribution. Now the next one is question number 8. The